Getting there. So welcome everyone, and hopefully we don't bore you too much about talking how we built 17 apps from a single code base. But those that know me from the past, they know that we don't like boring presentations here, so getting there. So we're gonna talk about the story of like where we come from, a story about monolithics, a story about how we're doing things here. And somebody dared me to do it again, and yeah, it's not gonna be a story, it's gonna be a musical. So I promise not gonna sing, I'm just gonna talk a little bit around of our journey of building applications. This Tuist is just a little perk that we bring in, and if you see that code on the bottom corner and those titles, if you guess all the 25 songs, please come back to me later. I will give you the playlist, and maybe also get you a beer. So let's dive into the void. What do we have here? Yeah, developers are very opinionated. You either love Xcode or you work at a project at a scale. And for us, it's more about the later. So if you're having a bit of a hard time, trust us, we know the pain. We hear those challenges around, but when you're building 17 applications, it's not that easy. We focus our project into a feature delivery approach where we have many commonalities between all of them. And as much as I would love those to be the code name for our projects, if anybody from product is around, I would love a Chaos and Inferno project coming up, just made up name. They are code names. You have heard some of those public up. Some of them are private internally, and we're about to launch. So we unleash the beast. How is it working with 17 projects around? I'm gonna tell you, it's not fun. It's a lot of pain that comes from it. So it's a bit of the compounding effect. Who has a single project attached to a workspace? No one. Who has a couple of them attached? No one. So they tend to be rare, but you tend to have multiple targets, either test targets, maybe you are looking for extensions and other capabilities. So yeah, we got plenty of those. And actually, as a finance institution, each one of our projects mostly is attached to a target. And we are simplifying the scope here. We're not adding all those extra tests and all the capabilities. It's like as raw as we try to make it. And also I like it looks a bit like a dandelion, so it's nice to have it all sorted. So we're not over yet. This is just like a first glimpse into what we do here, but it actually gets worse, much worse. Let's add dependencies. And yeah, it looks nasty. I think that even if you try to make it a bit more beauty by adding a great visualization for developer experience, it's still like very deep bowl of spaghetti that you're trying to hunt for that meatball, and you're just like failing. Every time that you try to touch any of the dependencies, everything moves together and you just want to cry inside. We love our application, but we gave it a name, BFA. Big stands for big, we all know. A for application, but trust me that F is not for functional. It was way too big, we hated its guts. But well, we keep on introducing new tenants, we keep on getting new partners, and the project keeps on growing, so we need to do something. We need to beat the heaviest matter of the universe that our project was becoming. What to do here? Well, we're doomed to find a better solution, and everybody knows that it's very fun when you're working in a greenfield project, but we have a project that we have been inheriting for years and years, and as much as I would love it, we cannot just rip it and tear it into pieces. We need to think thoroughly of like a modularization approach, how to take them on and how to make that dandelion fly. And that's exactly what my colleague Sergio is going to talk about. He's going to shed some light about our modularization process. So over to Sergio.
Okay, thank you, Juan. Can you guys hear me? Wonderful. So let's go back in time a few years when we're just starting our modularization journey here at NewDay on our iOS app. At that time, we were mainly using Cocoa Pods and manually linked frameworks on our modules. And we didn't have a lot of modules at that time, but we did quickly learn that that solution was not going to really work for us. We knew that we needed a solution that can basically automatically manage and resolve any internal and external dependency for us. And here's when Apple came to the rescue, because it provided us with the Swift Package Manager. And it really helped us a lot, no? Not only because it it manages our dependency automatically, but also because it's built into Xcode. So it was super simple to integrate for us, and it really helped us to streamline, to ramp up our modularization effort. So in terms of structure, we went for a fairly standard design, as you can see from the diagram, where we have a feature modules and core modules. Core modules were meant to be few, were meant to encapsulate reusable functionality, and if you in contrast, and they're supposed to be independent as well. So a core module should not import any other core module or any other module whatsoever. In contrast, when you look at the feature module, they can import any other any core module, and it's also the best place where you will be importing your external dependencies. The only constraint probably I would recommend here is that you don't make one feature module to import another feature module, and that can guarantee you a very shallow dependency graph and a good separation between all modules. Additional to that, we introduced the concept of test harness app. There's nothing more than another Xcode project attached to each of our modules with the intention of helping us to aid testability and improve our developer workflow. So as you probably anticipated, we started to see some major improvements in our project. So for example, some obvious one is that we got a better core organization. We got improvements in terms of scalability, reusability. So we were able to distribute our module better across our different teams. We started to see as well improvements on build time. And here I'm talking about build time of the main app. And what I mean here is that when you modularize your app, you're in essence helping the compiler to be smarter, which will make your build time shorter. We noticed as well that people started to spend more time working on the test harness app in contrast with the main app. And this day we can estimate that the engineers spend around 80% of the time on the test harness versus 20% on the main app. And that brings some improvements in terms of productivity for many reasons. One reason, for example, is that when you are working on a test harness app, you have a smaller code base, so your build times are shorter, faster, and your feedback loop is faster. So that makes you more productive. Another example is, when you can see on the example test harness that we have in the slide, you're able to define very easily very different use case and test scenarios that sometimes not that straightforward to do on the main app. So that as well makes your app, your development workflow a little more efficient as well. In the same way, when you're working on test harness app, the amount of code that you have, as I mentioned, it is smaller, so that your cognitive load is lower, so you're able to understand the problem faster and tackle these issues faster, so you're more productive that way as well. And this is even more noticeable when we have new joiners, for example. We didn't notice that the time it takes a new joiner to become fully productive was considerably lower than before, just by focusing that person in the core, in the feature module instead of working on the main app. And last but not least, we saw, of course, improvements in testability. We introduced, for example, selective testing, but Juan is going to elaborate a little bit more about that one later on. And we were able, for example, to introduce in a more efficient way our UI test, automated UI test. But everything was not a walk in the park. There were still some challenges that we need to address at this point. For example, from the developer experience, we saw an explosion of the amount of Xcode projects that we had to maintain. Now, remember that now we need to have like one extra Xcode project per module that contains the test harness. We saw there were some inconsistencies across those modules, because remember, again, these modules were manually generated. I remember at the time we even had a Confluence page with instructions on how to build and configure the module, and that's not great. We still had a conflict, so not as much as before when everything was a monolithic, but it remained a problem. Mainly, the decrease came from people started to work less on the main app and more on the test harness. But even more important than that, we have some very specific NewDay requirements, business requirements. For example, we were required that for apps to be able to pick and choose which feature modules they want to consume. And here I'm not only talking about feature flags. Here I'm talking about removing the feature entirely from the binary. So using, at this point, we didn't have an easy way to accomplish that task. No? Another requirement was that we wanted for our apps to be as brand agnostic as possible. And one of the biggest infractors of that initiative was the main scope project, where we have a lot of brand information baked into the project file. And it was manually entered using Xcode. And we don't have a clear way to extract that information out of the project, basically. So to recap, and for a little bit of a reality check here, we started with our big functional app. We still have it, so it has not gone anywhere. But now we have a bunch of little scope project or test harness app growing and getting a little bit out of control. No? Which reminded us a little bit of a movie from Steven Spielberg where people didn't follow instructions correctly and then things got a little bit out of control. No? So yeah, a bit scary, I know. But we knew that we had to do something, so we needed to go back to the drawing board, and that the standard project declaration that Xcode provides, it was not really working for us. No? That we needed probably a different approach. In this case, that approach was to move to a project generation approach. But what is the project generation? What are the difference between the standard and the project generation? Let's start with a simple example of how the standard project works. We all have been there. We just need to add one file to our project, or for example, add a new module, and then we just create a PR. But if somebody else have modified the project file as well, do a similar task, then you end up with a mess like that on your PR. But it's not any merge conflict that you got here. You got a merge conflict on your project file. And this is a massive file. And even for us, it's even bigger, because remember, we have 17 apps. So we need to deal with this, with this merge conflict in a far larger file, in a bigger amount of merge conflict at the same time. I don't know what happened there. Okay, it's back. Awesome. So definitely a productivity killer. In contrast, if we look into the project generation approach, you remove all that manual configuration that you did before using Xcode, and you just declare how do you want your project to look in a manifest. The manifest can be on Swift, or it can be on YAML, depending on the tool that you choose. And then this tool will just read that file, and then using that file, it will generate your project on demand for you on your local machine. So you don't longer need to commit those files into your repo, and eliminating altogether the option of merge conflicts. So we evaluated basically two tools at that time. There was Xcode Gen and Tuist, and they were both excellent tools, but we cannot decide to favor Tuist because it is Swift-based, so it was easy for our team to adopt. And as well, at that time, we have our own CLI tool also written in Swift. So for us, integrating Tuist into our CI was very simple and straightforward, and enabled us not only to take full advantage of the Tuist capabilities, but also extend some functionality to adapt to our own needs. And here came the second wave of big improvements in our project. No? At this point, merge conflict on the project file version for the past. We started to use a nice feature on Tuist scaffolding, where you can template your modules and then easily generate and consistently generate those modules. So we eliminated inconsistency in our different modules. We saw improvement in build times, because when Tuist generates your project, it uses frameworks directly on the generated project. And we found that it's faster to build your project when you have only framework, that in contrast if you have Swift Package Manager on it. And of course, we were able to remove all the test harness app Xcode project, around 1,000 lines per project, and we have over 44 modules, so there's a lot of lines of code. And yes, we were able to kill the whale. Not only that, we were able to open this awesome PR, and that was a massive milestone for our team. Not only because we were able to remove almost 57,000 lines of code that we really didn't need, but also we have improved a lot of developer experience, so we're quite happy with the results. So coming back to the business requirements, we were now able to easily remove modules on demand for specific apps. But I want to clarify here that the Tuist or any other project generation tool will only take you halfway of that job. The other halfway depends how well structured your module is. And we like to reference to this diagram from a book called The Philosophy of Software Design, where the author defined two different types of modules, a deep module and a shallow module. Being a deep module, the one that have a simple interface, but you can access a lot of functionality, and a shallow module, very complex interface, but you can access very little functionality. In simple words, the simpler your public interface of a module, the simpler it will be to remove it from your code base, or remove it or add it. And finally, from my side at least, the other requirement, this slide is more about our vision for the app. By removing the main scope project, we made our app more brand agnostic, so we were closer to becoming, or to making our project becoming an app factory. And what we mean about that is to be able to add new brands without adding new code or changing a single line of code. And that implies that, for example, it will be the same effort from the code point of view to maintain one app or, for example, 100 apps. And that kind of enables scalability and enable our teams to focus on features instead of the amount of runs that we need to support. So now I will give time to Juan again, and he will start talking a little bit more about our CI and our testing plans. Oh. Sorry, there we go.
Thank you. So I'm going to try to speak a bit louder so everybody can hear me. So back into testing, what do we do with our application? Now has been nicely modularized around. It's a matter of bringing it to the user. Let's do a bit of a shift here, focus shift in how can we put that application in the hands of our stakeholder, in the hands of our partners. And if we take a look at where we come from, yes, those are hours, awful, sorry, something that probably will start at midnight. If you are an early bird, you might still see running in the morning, say hi. Up on the top right corner, you can see the number of minutes. The first circle represents runtime, the second circle represents billable. We come from like a serial execution approach where we're running everything into Azure pipelines, great service. And we had reserved instances, so we just pay up front and abuse it as much as we want. So modularization is great, right? It's going to bring those numbers down. Wait, that's not great. We actually brought them up. What could be the reason about that? If we take an inner look, it's just a wrapper around multiple sets of projects that all need to be provisioned by their own. So we're talking about spinning up dependencies, building the project. And something that really scared us, that we actually duplicated those, so lunchtime, still running. Oof, you could barely run it during the day again. So if you talk to anyone, it's going to say like, well, the first course of actions here is like, modularize it, right? By the way, for simplicity, I only put in 10 of them. We have 50. The good news is that Azure pipelines is dirt cheap, very easy to get this running. So that's what we did. We just said like, hey, please, can we have 50 of those hosts? They said like, yeah, cool, just pay for them in advance. Very cheap. So at this point, Azure was a great solution. So that's it, right? We're just splitting them back. Wait, second problem. It's not that straightforward. By dividing them into separate processes, you're going to run on overhead, checkout, fetching external dependencies, and orchestration. So that parallel approach opens a different kind of worms. If you see on the top right-hand corner, skyrocketed up into the 3,000 minutes. It's a hell of a lot, but we will be burning every day. But who cares? We just pay up front for Azure. So we just need to let the project run and go out for a walk. Let it run around. So if somebody asks, yeah, it's testing, I'm going to take a look in 5 hours. The problem here is that, wait, 5 hours. We're not that far away from the original 6 hours that we started from. So why the hell did we modularize? Let's take a deeper look. Dask, for example. Initially, we just do like a checkout step. We bootstrap the project, fetch dependencies, build, unit test, and massive UI test in there. One by one, what can we do here? Check out, shallow clone it. We come from a very old code base, huge, so a lot of bad or different decisions during the time that we just need to fetch every time as we go on. A shallow clone it if you don't need the Git history. Avoid fetching tags, they add up. So if you just testing, unless you are releasing and you need to play with version controlling, you might not need those tags. Do you need LFS? Stands for large files system. Maybe you do, maybe you don't. A little bit more into that later, which also adds up to the amount that you're checking out. First, dependencies. Maybe take an approach where you can cache them. It's always faster to fetch them from disk or a cache rather than rebuilding them. But a bit of the elephant in the room, UI testing. And yes, the first thing that somebody's going to tell you, just don't animate the damn UI testing, just run them because the computer doesn't care about the fancy animation. And yeah, that's a good advice. But we went deeper. You actually need them? And we got our eyes into snapshot testing. And we realized that 90–95% of our tests could be simplified by moving them into snapshot testing. We could test the automata behind the screens and just rely into UI testing for actual user input and interaction. So we went all into snapshot testing, big lover of them. But what about the other boxes around? What else can we do here? So around build optimization, cannot see very much, but that's build assistant in Xcode, amazing tool, gets you like insight of like what is happening under the hood, what is your build step, why it's telling you that it's taking 10 minutes. And you want like a nicely compact, everything utilize course because don't forget, it's somebody else's computer, treat it like a loan car, abuse it as much as you want, you don't care. They pay the electricity, not you. So make sure that there are not custom scripts or any asset cataloging step that is eating up on that efficiency. There are many other ways to improve the building step. Many of them now come by default, so maybe you don't need to do anything. The second bit that we were very proud to see is that cool PR from Eric Jensen. If somebody meets him one day, please say hi. We saw like a massive improvement in our PR by just focusing into perceptual image perception. When you have two images, you might not need to compare them bit by bit. That's very CPU intensive. You might be able to compare that precision in a matrix level. So in this case, that's a 97% improvement, down from like a second average comparison of image to some millisecond approach. So yeah, thank you, Eric. We definitely use this and abuse it in our projects everywhere. So that brings us to like, where are we? We have a bunch of optimization that we were applying around. Can we bring down that 5 hours and a half? We can. But before, there are some trivial changes that you can do. Maybe you need to think of like, do you want to run your PRs when somebody opens a draft PR? Do you want to use the context and cancel it because somebody might just keep on clicking on like, accept suggestion, accept suggestion, accept suggestion, and just say like, don't need to run your CI. Or maybe, overall, you just want to use merge queues and separate how you apply your unit testing and your deployment, where you just apply that in a merge queue. It's a bit of a controversial, there are pros and cons of each, how you get that early feedback. But in our case, we thought, yeah, this is enough. How much enough? Now we're talking about 40 minutes time. That's great, right? 40 minutes, you can just come down here, have lunch. It's not a too bad thing. Well, probably we can do better, right? When we see that apply across the whole state, Dask here was one of our biggest modules. We passed from like those 5 hours and a half and 3,000 minutes execution time down to 40 minutes and just shy of over 1,200, not too bad. But remember, we don't pay for time, we just pay for runners, so great, who cares? Well, the paradox. The paradox of choices that we made here brought us to Azure Pipelines announcing, hey guys, we're going to be deprecating because somebody bought GitHub, and say like, why having two when you can have one, despite a lot of similarities? We also, as a company, wanted to achieve a lot of cohesion between our teams. We have plenty of experts in infrastructure and able to support us when we go into the GitHub action train. And most important, we're very heavy users of snapshot testing. And one of the things that we saw is like the testing and the cohesion differences between Apple Silicon generated images and Intel ones. There's a difference in behavior of how those shadows are computed by Metal, and that means that we all are lucky enough to have very last generation MacBooks. I'm not getting an Intel again, sorry. So we were left with no choice. Yeah, we're going into GitHub Actions, right? We're going to be paying per use. The benefit, Intel Silicon took us 40 minutes to run. Well, great news. Apple guys did everything for us. Now, we just have everything, so we can say like, yeah, we did something, but doing nothing, just moving to a different provider. We cut our time by half. Well, at this point, we made a little bit of a sleep. The thought of like passing from like a simple, you provision it and you abuse it as much as you want to like, now you're going to be paying for those minutes. It didn't take long from my boss to send me this message and say like, can you take a look? Seems that we're setting fire to money with mobile testing. Hi, David. Well, 15 left, right? We need them. They're our tests. We test a lot. We just change provider. We can probably do slightly better. And let's take a look. How can bad it be? Well, pretty bad. It actually scaled up by 1,400% our cost. And it's true that we were spending more in mobile than the whole engineering department combined and a little bit more extra. So what can we do? Well, our options are like, Xcode Cloud is great, but that means that we don't benefit from having all our expertise that we have in-house, all the overhead. Definitely, if you have the option, go for it. But self-hosted option, Spark in there. We could use self-hosting. But what is this? Well, one of the reasons probably is that, as you heard, Mac runners are 20 times the cost of your normal Linux one, because we all know that getting a Mac Mini M1 costs 20 times the same as a Linux server-grade infrastructure. I doubt it, but by the way, they're still M1, so I think that they got a very good ROI on those little machines. Well, obvious choice, game over, let's stop here. And I had a little talk with people inside and said like, this is now our CI/CD. And somebody internally made the joke, thought that we're moving away from self-hosting. Why would you want to have a little box in the office? And as much as I would have loved to have and sit in a throne of M1s and use it as a desk, because I will probably have paid off in like half a day, there are better that you can do. And that started to spark some creativity of like, you can combine both solutions. You're not tied to just one or the other. You can use the cloud as your fallback recovery. Like you run your own infrastructure and you self-hosted. GitHub is pretty flexible about this one. Listen to that in case something went wrong. Use them as your backup, because you're not going to have disaster recovery on site for your CI/CD. Probably it's going to be overkill, and argue why the cost went up. So at this point, yeah, N1, let's all jump on them. Let's make a purchase order and go into it. But try something different. Conditional approach. Do you really need to test everything? We jump in ourselves into a very modular approach, where we want to isolate pieces of code based on different functionality that we're doing. And that's when somebody can say around like that, of course, GitHub allows you to have scope of change. Like if you don't touch certain path, just don't run those tests. But for us, it was a bit tricky because we don't want the next developer that touches something else that depending on that original thing to be like, hey, wait, it's actually broken. And somebody's going to say, yeah, just run them on the nightly. Nobody checks the output of an eyelid the day after. That's something I'm going to tell you. We came up with something that we like to call like impact testing. Instead of just focusing into like the piece of code that has changed, focus into like the impact that that creates into your code base. We transverse the dependency graph to try to understand how the different relationships within the modules act and coalesce together. And we just craft a dynamic test matrix. Simple, right? Let's take a look. So in our case here, we have, again, an oversimplified, probably 10 of them. I cannot even count anymore. We have a lot more of those. So if we were to make a change in probably glow, what would you say? Just test glow, isolate that, and that's totally fine. But the issue here comes like, what if we are testing fume? Well, we need to isolate impact to dependent modules. So those modules that are importing the change that you're making. And in this case, it's very simple. Just create your dependency graph, transverse it, try to find those impacted changes. And yeah, somebody told me like, how you know somebody's building a DAG? I will tell you. Thank you, David. Extra perk, by converting the subgraph, you can get a very nice Mermaid diagram out of that. So you can just attach that to your README, make it very easily for new developers to join and try to understand how the whole spaghetti combines together at a smaller pace, and also check for changes. You can cache this dependency on disk because you're not expecting it to be changed that often. One thing I want to exhaust is like aim for foundational modules stability. Try not to change them that often because otherwise everything skyrockets up and boils like a pasta pot. Avoid deeply nesting your modules. That's something that Sergio was talking about before, how you have that silo versus deep module approach. And mostly, do you really need a module for that? Think about the size of the module that you're creating. Maybe you can just attach the functionality to something else. Just saying that you have 1,000 modules is not going to win you any prize. So keep it small. You're going to do yourself a favor. How does this all play together? So we did a bit of like a fan-out, fan-in approach here. So we first check for the changes that are happening. By the way, you can even run this into an Intel machine. You even have ARM right now, so very cheap. You build or fetch the dependency graph, git diff versus the target branch that you're trying to merge into, and set your testing strategy. One of the benefits that we saw here is that by generating a here doc string, we can avoid adding if-else statement like into the jobs themselves. So we're just creating that matrix from scratch, and we could manipulate that much neater. And at the end of it, what you do, you just fan into, you collate those results. And something that we did was like merge all the individual exit result tools, give that feedback as code coverage, and also support it for like the engineers that were debugging to be able to download from the Artifactory easily to check locally and be like, oh wait, yes, this is the issue I need to fix. So great. What does it mean? But our very heavy, bumpy CI now becomes a much linear approach. And we're looking statistically here. I know nobody likes them, but 95% of the cases, we saw them running below the 13-minute mark. Quite an improvement where we started from. And most important, 28 billable minutes. That's something a bit more digestible to say, like to pay for. But you might ask, yes, statistics are great, but what about those outliers? What that 5% give us? Well, it's our last resort, our salvation. It's going to be test plans, and yes, there are 2 songs for the price of 1 if you want to spot. So in our normal execution parallel run, we just see that that thing is skyrocket up to the 10 hours, but we can split the execution flow to understand how big is going to be the impact. We have historical data, and at this point is when we can make the decision, which we might want to. We probably want to run them in a serialized order through test plans. That is going to cost you only 45 minutes, worst case scenario, at a trade-off, 45 minutes of like feedback loop. You could always override this by adding tags or specific commands to your Git history. And that's something that kind of like fits our needs. As an extra perk, test plans give us the benefit of like going beyond that, scheduling them for our nightly execution and looking for like thread and memory sanitization problems. And we also could scale out into like different device sizes, accessibility areas, or even locales. So that comes at a cost of duration, but that was like a great tool for us to use. And yes, that 45 minutes is actually a 98.5 reduction for the original figure that we started with. Over 3,000 minutes burning money in our CI and gifting it. So the epilogue of all this story, why you hear us talking for so long. So that image on the right is the day that Sweden changed its driving from the left to the right. And I love it. I even printed it in full width on my wall in Sweden a long time ago in there. And that represents, like, despite all the planning and all the effort that you make to try to not screw it, trust me, you're going to make mistakes. Try to learn from those. All the work and all the effort that you put is going to be to help your developers, to have that developer experience going forward. And try to avoid the Maslow-Hammer dilemma. If you're just looking at a problem and you know how to apply something, think outside the box. What else can be done here? Don't just buy 200 Mac Minis. I mean, that makes a hell of a lot of effort, but it's such a problem for your IT department to set up. So avoid applying techniques meant for single projects when scaling, but I think that the most important when you're scaling a project is just fail. Learn from it. Thank you, Yoda. And hopefully you enjoyed our talk and there's something that you can take home with you. Feel free to reach out and any questions, here we are.